Hello everyone. This is physical world which we are going to start here. This is the first part of the first unit of class 11th physics. Now, the first topic here which we are going to discuss is what is physics. It is a branch of science which deals with the study of basic laws that governs and control the nature and natural phenomena. Always remember one thing, in physics, whenever we discuss any natural phenomena, it is on the basis of experimental evidence and facts. So the study of physics simply is the study of nature and natural phenomena on the basis of experimental evidence. Now there are different branches of physics that some of the branches are discussed here. First of all, we start with mechanics. It deals with the motion or equilibrium of a system of particles or rigid bodies. Basically, it follows all the Newtonian laws of mechanics. The next branch we can consider as thermodynamics, which is the study of the heat or temperature of a system of particles. Electrodynamics refers to the study of electricity, magnetism, electromagnetic waves, which includes laws like Coulomb's law, Oersted experiment, Ampere circuital law, Maxwell's equation. All these you are going to study in the syllabus of class 11th as well as in class 12th also. Then sound or acoustic. This is a separate branch, as you can understand from the name itself. Light and optics. This is also a very important branch of physics which deals with the study of light and the phenomena which are linked with light. Then a most important branch of physics is relativity. Relativity, it deals with the theory of invariance in nature and the motion of object moving with a speed comparable to the speed of light. You need to understand this. When a particle or a body start moving with a velocity comparable to 3 into 10 raised to the power 8 meter per second, which is the speed of light. Einstein said that a body cannot move with the velocity of light if it is not light itself. Light photons can only move with that velocity. But if you consider any particle which moves with a comparable velocity, like somewhat less than that velocity, then the mass, length and time will change, and that is studied in theory of relativity. One most important formula, E is equal to mc square, also comes from this. Nuclear physics deals with the study of nucleus of an atom. Particle physics deals with the ultimate particle with which matter is made of. And quantum mechanics deals with the mechanical behavior of particles of subatomic world. So these are some of the examples of different branches of physics. There are so many other branches, classical physics, then theoretical physics. There are so many, radiation physics. So all these are examples of physics. Now we move to the next part. Here, principal concept or principal basis in which physics depends. We call it principal thrust in physics. Actually, when we study physics, there are two important things which we should always remember. The first point is unification. Unification means if we are dealing with some different types of studies in which electricity, I am taking an example, suppose electricity, magnetism, electromagnetic waves are there. So these are different parts of physics, and if they are combined together, then the process of this combining and making it a unified one is known as unification. The example which I am quoting here is, suppose electricity study of magnetism, study of electromagnetic waves, these are all combined together by Maxwell in Maxwell's equation. So that is unification. Next is reduction. Reduction is the opposite process of unification, which is also very important in physics. In reduction, the bigger complex system we study by knowing their smaller parts. So that is reduction. I can quote one example so that you can understand it. Suppose the temperature, internal energy, entropy, these are the things which we study in thermodynamics for a system of large number of particles taken together. Now, this values of temperature are obtained from the study of behavior of the particles of the system. So this is reduction. We are dealing with the temperature of the whole system, but for that we need to find the temperature of the individual particles and their behavior needs to be known. So that is reduction. So I hope this is clear. Now, physics in relation to other branches of science. Let us quickly discuss this. Physics in relation to mathematics. Like in physics, we need to deal with certain problems which gave rise to some of the portions of mathematics, such as differentiation, integration. So many theorems are there, like Bernoulli's theorem. So these are the theorems and equations, and calculus, integration, differentiation, all these are the part of maths which actually was the need of physics for which they developed themselves. Then physics in relation to chemistry, like when we consider bonding between the atoms and molecules, so the kind of force of attraction or repulsion, all these are related to the equations in physics. In biology, we discuss or we take the help of physics, like X-rays, all the discovery of X-ray and the use of it, and then the use of radiology, the use of microscopes and other things. So these all, in this way, physics is linked to biology. In geology, the study of crystal structure of rocks, this includes the physics in geology. Then in meteorological studies, like in weather forecasting, the temperature and pressure related information deals with physics. In seismology, that is the prediction of earthquake when it's studied, the vibrations which are produced in the earth crust, the study of it is linked with, again, physics. So physics is linked with many other disciplines of science. Now, physics and technology are also related, and they are related to our daily and routine life things which we are using. Like here is a chart which you can go through the chart. Here you will see that in the left hand column technology is written, and the right hand column the principle of physics which is behind it is written. I am quoting some of the examples only. Like refrigerator, you will find that it is based on the law of thermodynamics. Computer based on digital logic. Television based on electromagnetic waves. Radio also electromagnetic waves. Nuclear power generators. Controlled nuclear fusion it is fission reaction. Because of some reason it is written wrongly, you need to get it corrected. Then sonar, reflection of ultrasonic waves. So these are some of the examples. You can go through all the examples, and you will see that how everyday life of ours are linked with the principles of physics. Now we will discuss the scientific method, which is very much required in physics, so that we actually understand the nature and the natural phenomena. The first thing which we do is we observe a natural phenomena. We take readings, we see what is happening, and all these observations we make it note of all the observation. The second step of the scientific method is, based on those observations we draw a hypothesis. That is, we assume that the reason of these observations are something which we can consider. So that is hypothesis, the assumption of the observations, the reasons of assumption of the observations. Now the third part is, whatever hypothesis we have derived, now those hypotheses are to be tested whether it is correct or not. So for that, experimentation is done, like many experiments, to prove that the hypothesis is correct. After doing the experiment, we come to the conclusion. In the conclusion, if we find that the hypothesis is correct by performing the experiment, then we come to the conclusion that the hypothesis is a law which we will always follow. Let me take a very simple example. Newton has seen that an apple is falling down from a tree. So falling down of an apple is observation. The hypothesis he drew was, he thought that there must be some force which is pulling the apple down towards the earth. That was hypothesis. Then experimentally it is proved that there is some force, that is the gravitational force, which attracts the apple towards the earth. Then finally the conclusion came that the hypothesis is correct. So this is a scientific method in which we conclude everything, every natural phenomenon. So I hope that when you go through the video, everything is clear to you. If there is any doubt, you can post me the doubt, and make sure that nothing remains unclear to you. Thank you.